Hello, and welcome to Calculus, Lesson 18. Today, we are going to study some difference, product, and quotients of functions, as well as composite functions. Now, this should be a pretty reviewy lesson for you, as we've done all these things already. But let's define a function f of x. Remember, f of x is not f times x. It's saying the function's name is f, and it's receiving an input called x. Let's call f of x the square root of x. Let's call g of x x squared. Okay? Negative x squared. We'll make it fun. Okay. So what would I do if I had f plus g of 2? Well, I would take f of 2 plus g of 2. F of 2 is the square root of 2. That's gross. Let's use 4. So the square root of 4 plus negative 4 squared. So that looks like 2 minus 16, which is 14. Not too bad. When we subtract functions, we do the same thing, except this time, put a minus sign. Let's see, what is 2 plus 16? That looks like 18. Now, we also have a notation for multiplying functions. Well, that line did not go straight. Fg of x. So if I multiply two functions, that's the same as me taking f of x times g of x. So using our example for 4, that would be the square root of 4 times negative 4 squared. So that looks like 2 times negative 16, which is negative 32. Finally, that line's better. We can divide f over g of 4. That would be f of 4, or the square root of 4, divided by g of 4, which is negative 4 squared. So it looks like 2 over 16 negative, which is negative 1/8. Now, that's all review from many, many years ago in Algebra 1. Likewise, we are going to do composition of functions. So that's when one function is inside of another function. We will use this notation to denote that f is the outside function and g is the inside function. You have to get really good at identifying these so that you can do further calculus problems later. Now, so this is f composite g of x. That means g of x is inside of f of x. Conversely, g composite f of x would mean that g is on the outside and f is on the inside. So if I had f composite g of 4, then what we would do, actually, let's do g composite f so we don't break things, is I would take g of f of 4. So what's f of 4? Well, f of 4 was the square root of 4. So that's 2. So now I'm going to do g of 2. G was negative x squared, so it's negative 2 squared, which is negative 4. Okay? In this case, if I switch it and do f of g of 4, it actually has no solution because we have to take square root of a negative number. Okay? So, they will ask you to form some composite functions. So instead of plugging in numbers, you're going to actually plug in x. So they are saying f of x is now x squared plus 2, and g of x is 3x plus 5. And they want us to form f composite g of x. So what would f composite g of x be? Well, that's the same as f of g of x, or f of 3x plus 5. So what happens when I plug in 3x plus 5 to f? Well, f is x squared plus 2, and I'm going to plug in 3x plus 5. Now, they ask a sneaky question here, which is, what is the domain of this function? what numbers can you plug in? In this case, there's no restriction on the domain. The domain is the real numbers. Why is it the real numbers? Because I can take any number and square it and add 2. Okay, that's fine. But sometimes we'll have trickier problems that do not lend themselves as easily to finding the domain. So, let's see here. F of x is 2 plus sine of x. And g of x is x minus pi over 2. And we are to find f of g of x. State the domain and range this time. So g of x is x minus pi over 2. So this would be f of x minus pi over 2. And I'm going to plug in this into f. So f takes in an input x. So I'm going to plug in this for x. So that gives me okay. We're not bothered by that. What is the domain of this function? What numbers can I plug in to sine? Well, I can plug in any number I want to sine. What numbers am I going to get out of sine? Well, sine, if we're asked to find the range, sine will only give us values out between -1 and 1. If I add 2 to that, it looks like the range. Follow me here. Why did I put x is? Domain. X is in the real numbers. Range. X is, man, I'm getting sloppy today. Sorry, guys. X is in the real numbers. And 2 plus -1 is 1. 2 plus 1 is 3. So x is between 1 and 3 because if we just had sine of something, we would get numbers out -1 to 1. If I add 2 to that, I get 1 to 3. Now the last part of our lesson is that they're going to have you actually decompose the functions yourself. So they're going to give you a composite function, perhaps like this one. And ask you to find f and g if this is f of g of x. So what could the inside function be? Well, the easiest inside function is the function that is completely inside of the other one. So I would choose, and I would encourage you to choose, g of x equals -2x plus 1. What does that allow you to do? That allows you to replace and say, oh, well, this is just e to the g of x, right? And since this is f of g of x, then f simply equals e to the x. It doesn't equal e to the g of x, it equals e to the x. And then we plugged in g of x. So this would be your answer if they ask you to decompose that function. Take the inside part, call that g, take the outside part, call that f, and then replace whatever g was with x. That, my friends, is problem set 18.